Hello, fifth graders. Mrs. Webb bringing you science. Unit 4, Lesson 4. How do shadows change during the day and year? How do shadows change during the day and year? What do you see in this image? Did you see 5 people walking on a dirt path? Do you see their shadows and how short they are? What do you notice about the direction that all of their shadows are pointing? What is creating this family's shadows? That's right, the sun is creating their shadows. The sun must be up high in the sky in the opposite direction of their shadows. Do you think their shadows will look the same all day long? Probably not. Shadows formed by the sun change length and direction throughout the day. Are you ready to learn more? Let's start by observing our phenomenon. Shadows move and change length throughout the day. Watch the shadow of this tree in this time-lapse video. What is happening to the shadow? What is causing it to move? How would you describe the change? At the end of this lesson, you should be able to explain the phenomenon. Shadows move and change length throughout the day. I'm going to show you a demonstration of how shadows move and change length throughout the day. And to show you a demonstration, I need to use a model. I have chosen this as my model. This is a ball, and it is representing Earth. On that ball, I have attached a sticky note with north, south, east, west, and a long pole, as you will, that will represent somebody maybe standing or an actual pole standing on the earth as we look at the shadows. I have also marked 2 other locations. I have location number 2 right here and location number 3 right here. And I'm going to show you a demonstration of how shadows move throughout the day in those 3 different locations. I have placed my model Earth in front of my model Sun. You can see the sun shining on the ball. I'm going to simulate the Earth's rotation by turning the ball. We will be pausing to observe the shadow at 5 different times during a day. Sunrise, mid-morning, noon, mid-afternoon, and sunset. We will be observing the direction that the shadow is pointing and the length of the shadow. I will be recording the data that we collect on this chart. Location 1. The Earth is rotating. I'm going to stop when I see the first shadow at sunrise. This is the shadow that we are looking at. Look how long it is and the direction that it is pointing. Let's record the data from our observations. We can see that the shadow is pointing west. I measured these shadows off camera. This shadow was about 4 centimeters long. Let's continue to rotate and stop at mid-morning. Did you see the shadow move? Which direction is it pointing now? Right between north and west, we would call that northwest. Did you notice the length changed? I measured it at 3 centimeters. Let's continue to rotate the Earth as it gets later in the day. It's now noon or 12 o'clock. Notice the direction the shadow moved and the length of the shadow now. Did the shadow get longer or shorter? Let's record our data. This shadow is pointing north and it is 1 centimeter long. And now it is mid-afternoon. Observe the direction the shadow is pointing and the change in length. The shadow is now pointing in between north and east, northeast, and the shadow got longer. It is 3 centimeters. The world continues to turn, and now it is sunset. What direction is the shadow pointing now? Did the length of the shadow change? The shadow is now pointing east, and the length of the shadow is 4 centimeters. Let's look for some patterns in our data. First, let's look at the direction. Just reading through the day, the shadow went west, northwest, north, northeast, east. Now let's look at the length of the shadow. 3 centimeters, 1 centimeter, 3 centimeters, 4 centimeters. How would you describe those patterns? The shadow starts long, gets shorter at noon, then gets long again. The shadow points west at sunrise, north at noon, and east at sunset. Let's look at another location. I moved my post and sticky note to location 2 on the ball, which represents and models the Earth. I'm going to show you these fairly quickly, and I'll put the data in at the end. Sunrise, the shadow is pointing west and is about 3.5 centimeters. Mid-morning, the shadow is pointing northwest and is 2 centimeters long. Noon, the shadow is pointing north, and you can barely see it, maybe 1/2 centimeter. Mid-afternoon, the shadow is pointing northeast and is about 2 centimeters. Sunset, the shadow is pointing east and is 3.5 centimeters long. Let's look at the data we collected. Compare location 2's data to location 1. Compare and contrast. What is the same? What is different? The direction that the shadow points throughout the day is the same for both locations. The pattern of length is the same. It's long at sunrise, short at noon, and long again at sunset. What is different about the data for location 2? The length of the shadows is different. What can you predict about the direction and the length of the shadows for location 3? Let's find out. Sunrise, the shadow is pointing west and is 4.5 centimeters long. Mid-morning, the shadow is pointing northwest and is 3.5 centimeters long. Noon, the shadow is pointing north and is 1.5 centimeters long. Mid-afternoon, the shadow is pointing northeast and is 3.5 centimeters long. Sunset, the shadow is pointing east and is 4.5 centimeters long. Now compare the data for all 3 locations. What patterns do you see? For all 3 locations, we see that shadows start long, get shorter at noon, then get long again. For all 3 locations, the shadow points west at sunrise, north at noon, and east at sunset. Can you use these patterns as evidence to explain the phenomenon? Shadows move and change length throughout the day. Now it's time to show what you know. Don't forget to go back to my science page and click on Show What You Know.